Have you ever wondered what keeps your morning coffee from flying all over your dashboard when you hit an unexpected pothole? Or how your car manages to stay so calm and collected while driving over a rough, bumpy road? The answer, my friends, is not magic. It is a brilliant piece of engineering called the suspension system. Think of it as the unsung hero of your vehicle working tirelessly beneath you. It's a complex network of springs, shocks, and linkages that connects your car's body to its wheels. Without it, every single drive would feel like an off-road adventure, and not in a fun way. The importance of your car's suspension goes far beyond just providing a comfortable ride. It plays a critical role in the safety and handling of your vehicle. A good suspension system is designed to do two main jobs simultaneously. First, it absorbs the energy from bumps, dips, and cracks in the road, isolating the cabin from these disturbances. Second, and arguably more important, it works to keep your tires firmly planted on the road surface at all times. This constant contact is absolutely essential for maintaining traction. Let's break down the core components of your car's suspension into its three main players: springs, shock absorbers, and struts. First up, we have the springs. Their job is simple but crucial. They hold up the weight of the car and absorb the initial impact from bumps in the road. However, if you only had springs, your car would continue to bounce up and down like a pogo stick long after the bump was gone, which would be quite nauseating and unsafe. This is where the second key component comes in: the shock absorber. A shock absorber, also known as a damper, is a hydraulic piston-like device filled with oil. Its purpose is to control or dampen the unwanted bouncing motion of the spring. As the spring compresses and rebounds, the shock absorber forces oil through tiny passages inside it. So while the spring handles the big hit, the shock absorber is what delivers the smooth, controlled ride we all appreciate. Now, what about struts? A strut is essentially a clever combination of a shock absorber and a spring into a single, integrated unit. In this design, the strut not only provides the damping function of a shock absorber and the support of a spring, but it also serves as a structural part of the suspension. It acts as a pivot point for the steering and helps to hold the wheel alignment in place. This makes struts a very efficient and space-saving solution, which is why they are so popular in many modern passenger cars, especially for the front wheels where space is often at a premium. Not all suspension systems are created equal. Different designs are used to meet different goals. One of the most common types is the MacPherson strut. This design is brilliant in its simplicity. It uses a single control arm at the bottom and the strut assembly itself at the top. This compact setup is inexpensive to manufacture and takes up very little space. Its simplicity means fewer moving parts, which can lead to lower maintenance costs. For those seeking higher performance and better handling, the double wishbone suspension is a popular choice. This design uses two A-shaped arms, one on top and one on bottom. This setup offers engineers much more control over the wheel's movement. It helps keep the tire's contact patch flat against the road, even during cornering or over bumps. This results in superior grip, better handling, and more predictable steering. Going back to a more traditional design, we have leaf springs. You'll find these on the rear of trucks and heavy-duty vans. A leaf spring is a stack of long, curved steel plates bundled together. This simple, strong design is excellent at supporting very heavy loads, which is why it's been the go-to choice for work vehicles for over a century. Finally, we have the pinnacle of modern comfort: air suspension. This system uses flexible rubber bags inflated with compressed air. An onboard compressor can adjust the air pressure in each bag, allowing the system to change ride height and stiffness on the fly. So how do all these components work together to make a jarring pothole feel like a minor ripple? Well, it all comes down to the fundamental job of the suspension, allowing the wheels to move independently of the car's body. Imagine you are driving along a perfectly smooth road. Your suspension is relatively relaxed, just supporting the weight of the car. Now your front right tire is about to hit a bump. Without suspension, the entire front right corner of the car would be violently thrown upward, sending a jolt through the entire vehicle and its occupants. This is where the magic happens. Instead of the whole car lurching upward, the suspension system allows the wheel to move up by itself. The spring compresses, absorbing the sudden upward force like a cushion. This action isolates the main body of the car from the initial sharp impact. The energy that would have jolted you is instead stored momentarily in the compressed spring. As the wheel passes over the peak of the bump and starts to come down the other side, the spring begins to expand, The spring pushes the wheel back down towards the road surface. This ensures the tire quickly regains contact with the pavement, which is crucial for maintaining control of the vehicle. But as we discussed earlier, a spring alone would just keep bouncing. This is where the shock absorber steps in to manage the energy. As the spring compresses and then rebounds, the shock absorber resists this motion. It turns that bouncing energy into heat, effectively calming the spring's oscillations. This is what prevents your car from continuing to bob up and down long after the bump is gone. The result is a single, gentle movement rather than a series of jarring bounces. This entire sequence happens in a fraction of a second, and it happens for every single bump, dip, and imperfection your tires encounter. While a smooth ride is certainly a major benefit, the most important job of your car's suspension is ensuring your safety. This is achieved by maximizing the friction, or grip, between your tires and the road. Think about what happens when you turn the steering wheel. You are instructing your front tires to change direction, and the car follows. This only works if the tires have enough grip on the pavement to execute that command. The same principle applies to braking. When you hit the brakes hard, the car's weight shifts forward. Your suspension system must manage this forward weight transfer to keep all four tires on the ground and braking effectively. Just as engines and electronics have evolved, so too have suspension systems. The latest advancements are moving beyond passive components into the realm of intelligent, adaptive systems that can think and react in real time. The first step in this evolution is known as adaptive or semi-active suspension. These systems use electronically controlled valves inside the shock absorbers. A central computer takes in data from various sensors around the car and then adjusts the stiffness of the shocks accordingly. Imagine you are cruising comfortably on a smooth highway. The system will set the shock absorbers to a soft setting, prioritizing a plush, luxurious ride. But then, you suddenly swerve to avoid an obstacle. The computer instantly detects the sharp steering input and immediately stiffens the outside shock absorbers. The next level up from adaptive is fully active suspension. While adaptive systems can only change the damping stiffness, active systems can actually push back. They replace traditional springs and shock absorbers with powerful hydraulic or electromagnetic actuators at each wheel. These actuators can actively lift a wheel or push it down with incredible speed and force. If a sensor detects a wheel is about to hit a bump, the system can lift the wheel over it. If it detects the car's body starting to lean in a corner, it can apply an opposing force to keep the car perfectly flat. This technology can virtually eliminate body roll, brake dive, and squat during acceleration. These advanced systems offer a level of ride quality and handling that was once unimaginable. Your car's suspension is built to be durable, but like any mechanical system, its components can wear out over time. The good news is that your car will often give you some clear warning signs that its suspension needs attention. One of the most common symptoms is a noticeably bouncier or rougher ride. If you find yourself feeling every little crack in the road, or if your car continues to bounce up and down long after hitting a bump, it's a strong indicator that your shock absorbers or struts are worn out. Another telltale sign can be heard or felt during turns. If you hear clunking or knocking noises when going over bumps, or notice that your car seems to lean or sway excessively when you take a corner, it could point to a problem. One of the easiest ways to check your shocks or struts is with a simple bounce test. When your car is parked, go to one corner and push down firmly on the fender several times to get the car bouncing. Then, let go. A car with healthy shocks should rebound once and then settle. If the car continues to bounce 2, 3, or more times, the shocks at that corner are likely worn and in need of replacement. For most drivers, suspension maintenance is straightforward. The most important thing you can do is have the system inspected regularly, perhaps during your routine oil change or tire rotation. They can check for worn or damaged components, look for leaks from the shocks or struts, and ensure everything is tight and in good working order. Also, pay attention to your tire pressure, as properly inflated tires are the first line of defense. By listening to your car and performing these simple checks, you can catch problems early, ensuring your suspension continues to provide the safe, comfortable, and controlled ride you depend on every day.